So that's lucky. Well, we'll have your periodic table.
Why are you stealing?
So then, I think we're going over some topics.
This
Just like this.
AP.
Yeah, me too.
I'll make no credits good.
Yeah, that's right.
Good morning, ladies and gentlemen. How are we doing today? Why? You chose to sit by Eric. That's not my fault. Yesterday, why were all the VBs gone?
I don't know. I had a dentist. I
Whatever.
have no excuse.
Whatever. Oh, Hamza, Killian, Sasha, Pierce, Ed, Jack, Irving. Irving's back there.
Bro, you can't even read your own numbers.
All right, give me something about Boyle's Law. Angle, get us started.
I forgot.
Well, find something. Figure it out. Come on, let's go.
Yes, I'm going.
Can I?
Today, I want to know one thing about Boyle's Law. Let's go.
The pressure of a gas will vary inversely proportionally to its volume and a constant temperature.
Okay, what does that mean?
I don't know.
Then why would you give me that?
I found it. Oh, P1 times V1 equals P2 times V2.
Good. Pierce, give me something about Boyle's Law. Jonesy, give me something about Boyle's Law. I'm coming back to you, Pierce. There's going to be less options for you.
P and B are in inverse relationship.
P and B are an inverse relationship. Shenzi, give me something about Boyle's Law.
It's about gas.
It's about a gas. Good. Jack, give me something about Boyle's Law. T and N are held constant. All these people are stealing multiple things. Phoebe.
Yes.
Phoebe, pick a different one then.
P means pressure.
What?
P means
Good. Pierce.
how is that in that?
Oh, right. I forgot about that.
Oh, the X.
Something about Boyle's Law, Pierce.
Oh.
Shush, you already gave one.
No, I'm not.
Shush, you already gave one.
To be like a square.
Hey, pay attention. B is for volume. Good. Go ahead, Christopher. Then figure something out. Give me something about Boyle's Law. What? We can wait. Go ahead. Find something. Yeah. Come on. Let's go. Find something. Something out about Boyle's Law. I don't know. Not an acceptable answer. Give me something.
Pressure and volume are constant.
In Boyle's Law?
Get this one.
Oh, V equals volume.
Already given. Sorry.
K is constant.
Okay. K is a constant. Good, Jaden.
Boyle is spelled with a B.
Oh, Boyle is spelled with a B. How else would it be spelled?
No.
Well, give me the whole spelling. That way somebody else can't steal that one.
O-Y-L-E-S.
Okay. All right. Okay, Achilles.
More volume, less pressure.
More volume, less pressure. Okay, good, Maddie. Not an acceptable answer.
T and N are constant.
Yep, we already said that. What's T represent? Okay, good. Moving on along, Joshua. And is the amount of gas. Go ahead, Joshua.
It is very important.
Why?
Because it shows
I
how much
know.
pressure. Exactly how much pressure.
Exactly how much pressure it is. You're actually close. I'll let you keep working through this. Come on. To know how much pressure it is, you would have to know how much what? Steven's turning his back on you. He doesn't realize he's next.
How much force you use?
No. We never did force when we talked about these things. Well, if you have a pressure, you also have to have a... Good to know you were paying attention yesterday. If you have a pressure, you also have to have a... Oh, good. Steven, go with that.
Did they already say that N stays the same?
Yes, multiple times.
Oh.
And we even know that N represents the amount of gas.
Pressure is the constant bombardment of particles on walls of container.
Oh, very good. Okay, I'll take that. Eric.
Breathing is an example of the law, Boiler's law. Yeah.
Who's Boiler? When did we switch laws?
No.
No.
Hold on.
Let me clarify what I
Boyle's
don't
law.
know.
How do you say it? Boyle's law. How do you say
How
it?
is breathing an example of Boyle's law?
When you breathe in, when your lungs expand, your
This is called painting yourself in a corner, ladies and gentlemen. Please go ahead, continue. I anxiously await.
as your lungs expand, something inside increases. I forget what it is.
Good.
But it changes its volume, and I'm guessing like the pressure would decrease. Try it. Breathe.
You can always call for water.
Hey.
You want to try something that actually makes sense?
I don't know. Everything's been taken.
Nope, hasn't.
Let's see. Did we say that T stands for temperature?
Yes, we did.
Did we say that P1 times pressure times volume equals P2 times V2?
Yeah.
Constant is a number that doesn't change.
Hey, that one we hadn't said. Okay, we'll take that one. All right. Good. All right, Faith, last one.
V times P equals K.
Yeah, we hadn't said that one either.
Okay.
V times P equals K. P times V also equals K.
Oh,
What's K, Eric?
constant.
What does that mean?
a number that doesn't change.
So if you have the pressure of a gas and the volume of a gas and it equals a constant, and then we change the pressure of the gas, what will happen? Yes, it is a constant still. Which allows us to then do what? You have a pressure and a volume of a gas. We change the pressure on the gas. What are we then able to predict? The new volume. Because they do equal a constant. And you will continue to have a constant as long as you don't change what? You will continue to have a constant as long as you do not change what? Temperature and amount of gas. So understand, a constant is a number that doesn't what, Eric?
Change.
Doesn't change. But the constant in gas laws, the constant in Boyle's law, is not an all-time constant. Meaning it is not always the same exact number. The constant is established by taking a pressure times a volume, giving you some number. A number that will not change as long as you do not change the temperature of the gas and you do not change the amount of gas. However, someone else may take a pressure and volume of a gas at a different temperature and at a different amount of gas and therefore get a different pressure times volume equals constant. But what I'm trying to stress to you is not every constant in Boyle's law is the same. The constant is for the gas under the conditions it is at. A different gas under a different set of conditions will give a different constant. But again, if we change that gas's conditions, we can predict what the new pressure would be if we know the volume, or the new volume would be if we know the pressure. That's what Boyle's law allows us to do. Questions? Now, who gave us the definition of pressure? Stephen, I think it was you, correct? Which is what?
Pressure is the constant bombardment of particles on the containers of the wall.
Okay. So,
Walls container.
containers of the walls of the container, however you want to say it. It is basically how often the gas particles inside a container hit the walls. Okay? So why does making the volume smaller make pressure go up? Why? Okay. Now we did not change the what? We didn't change the number of gas molecules in there. If we had put more gas molecules in there, what would happen to how often they hit the wall? What? Well, let's just say it would increase. Again, let's not make the prediction of a lot or a little because then we get into determining what is a lot or a little. But if we add more gas, what's going to happen to the amount of times they hit the wall? It's going to increase. What happens if we remove gas? Not going to hit the walls as much. So we're always thinking about pressure in terms of how often particles hit the wall. So if we were to make this room smaller, why would the pressure in here increase? What?
The particle face the wall is more often.
Why?
Plus less distance. Smaller.
Okay, the particles aren't going to travel any faster because then we would be changing the what?
Temperature.
The temperature. But if it takes a particle 2 seconds to get from that wall over here and hit this wall, it's going to take it 2 seconds to go back. So one particle hitting the wall every 2 seconds, correct? But we move this wall halfway, right here. Now what does that mean? What?
1 second.
It only takes 1 second to get across the room and hit the other wall. And which is more often, hitting the wall every 2 seconds or hitting the wall every 1 second? So we always want to go back and think about this, and it's hard to imagine these things. But we want to go back and think about it in terms of the particles. What are we doing to the particles? we putting more particles in? Are we putting fewer particles in? Are we making the particles move faster? Are we making them move slower? Okay? When we change the volume, the particles don't move any faster or any slower, but because the container walls are closer, you should hit them more often. That is what causes pressure to increase. Now, the nice part about Boyle's law is we can make predictions. You know a pressure, you know a volume, we can figure any new pressure or any new volume you want. Any one. Now, when we do our calculations, what do we have to do with temperature? Calcium.
Calvin.
It's a Kelvin.
What?
Cal-
No!
K.
No!
It makes it temperature.
I understand that. Why don't we need to do that in Boyle's law? Because temperature isn't in Boyle's law. Temperature is a constant. You don't have to worry about it. Okay? You don't have to worry about it. It's not part of any calculation right now. So you're right, Shenza. When we do get to the point where temperature is in a calculation, we're going to have to convert it into Kelvin. Not calcium, but Kelvin. Okay? But right now it's not in our calculation, so we don't have to worry about it. Okay? We don't have to worry about it. What do we need to worry about in terms of units, though? In a calculation, in terms of units, what do we need to worry about? Okay, well, that's afterwards. What about it? Okay, what about it? P1 V1 equals P2 V2. What do we got to worry about with units?
They have to see.
What?
The unit has to see.
That it matches up.
What do you mean matches up?
That like P1 matches up with P2 and V1 matches up with V.
It doesn't matter what units you are selecting. You want to do mmHg, you want to do PSI, you want to do kPa, you want to do atmospheres, it doesn't matter. But your units have to be the same on both sides. If they are not, you cannot do the calculation. Same thing, it doesn't matter what unit you want to use for volume. You want to use cubic centimeters, go ahead. You want to use milliliters, go ahead. You want to use liters, go ahead. The unit does not matter as long as the units are the same on both sides of the calculation. If they're not, you got to get them into the same unit and then do the calculation. Questions? Okay. All right. Excellent.
Wait, can we do a practice problem?
Certainly. Certainly. Take out your packet that I gave you yesterday, ladies and gentlemen. Okay, pick a number.
How big? Like how big of a number?
Well, under the ones that are under Boyle's law,
Let's do 3.
let's do 3. Okay, so here we go, ladies and gentlemen. Let's do number 3. A gas in a 15-liter container exerts a pressure of 99.5 kPa at 55 degrees Celsius. Assuming no temperature change, what volume is needed for the pressure to double? Okay, so Boyle's law, P1 V1 equals P2 V2, correct? P1 V1 equals P2 V2. All right, what's P1?
99.5.
How do you know that's a pressure, Eric?
Because that's kPa.
Okay, it has kPa in it. Very good. Okay, what's the volume that goes with that pressure? Okay, what's P2?
199.
What?
199.
Where'd you get that?
I doubled 99.5.
Okay, 99.5 doubled. $199, right? Am I right? So P2, 199 kPa. By the way, I am never worried about sig figs in the middle of a problem. You double 99.5, you write it as 199, you write it as 199.0. I don't care. I'm not grading you on sig figs throughout the problem, only in your final answer. Okay? And then we get V2. Now, all of these problems are going to set up this way because this is your formula. So how do we solve for V2 here? What do we mathematically do?
Divide by 199.
We divide by the number that we are supposed to be multiplying it by. And what you do to one side of an equation, you do to the other. Now, these cancel, right? Leaving only V2. What happens to our units of KPA over here? They cancel. So again, units are always important in science, ladies and gentlemen, but especially in chemistry. Because when you're done, if you're not in the right unit, probably made a mistake somewhere along the line, mathematically. Our units of KPA cancel. What is the only unit that is left on that side of the equation? Liters. Okay? Do the math. Tell me what you come up with. Bingo?
Bingo.
You came up with the number bingo. Let me see how that is displayed on your calculator.
Bingo, yeah. No, 7.5. But since 3 6 grades 0, so 7.5.
Yeah. Now, what happened to our pressure here?
Decrease.
How much?
Double.
Double. What happened to our volume?
Decrease.
How much? Don't say doubled. Our volume decreased by doubling. By 1/2. Whatever factor pressure goes up by, volume goes down by that same factor. So it went down by 2, divided by 2. That's how you can do the math in your head real quick. But again, sometimes it's not that easy. Most of the time it's not. But having an idea of what your volume or what your pressure is going to do is always a good idea. Since our pressure is going up here, what does our volume have to do? Go down. So again, at least we know we should end up with a number less than 15. Smaller than 15. Questions? Now, you can only do the first 4 problems on this page. Get them done right now. Get them done. Ladies, gentlemen, when you take the charging blocks from up here, can you please just unplug them from my cords and grab the other cord and bring it to your thing? Don't take my cords all the way out of here because they are eventually plugged into something underneath, okay? So I've tried to make it a little bit easier for you guys to get them. I've also tried to make it so they're more charged for you, okay? I'd really like to make it so they weren't in my class, but obviously that will not be happening anytime soon. So, all right, get these 4 done, ladies and gentlemen. Yes, Josie, what can I do for you?
Is the quiz on paper or the Chromebook?
The quiz is on paper.
Okay.
I doubt very highly until Unit 8 that you will be doing a quiz on the computer again.
Because this thing's gonna die.
And maybe even then you won't be doing it on a computer.
Then I'm gonna let it die. So then
Let it die! Let it die!
I'm gonna let it die. So
Okay.
How about
Right. Use it as a way of getting out of work.
I will do it only for ELA classes.
It's good. You'll do work for them, but not for me. Thank you very much.
This is like,
Thank you very much.
because I was up for, I was like looking to see if you were gonna post the video on your teaching thing, and you didn't post the video yet, so I was stressing
For which?
for it yesterday.
It's posted, isn't it?
I didn't see it. I didn't see it.
621.
When I looked for it, I was looking for it last night, and I looked for it this morning during first hour, and I didn't see it. But that could just be.
23, 12, 20, chemistry B. Oh, sorry. It's private still. Sorry, my bad. That's why.
Okay. I tried to watch it, but then I didn't know if you posted it or when you posted it.
Nope, I'm sorry. I just didn't switch it to public.
You're all good.
Sorry.
I'm here
My
now,
bad.
so
My
it
bad.
doesn't matter anymore. I'll watch it.
My bad.
actually pretty easy. So far.
Just be glad someone's watching those videos. I only listen to the ones with the nails because the audio is just really cool.
I was like, I just have a I'm just Just kidding.
And that's all the
I haven't
I
done
worked
that.
for 3 days.
So the first pressure was 105 kPa, so that's what we would put for P1. That was our first pressure. Our first volume was 269 milliliters of volume, so we put the
I was
first
talking to
volume
Beach last night because we were
equals
talking about passwords.
we don't have the second pressure, that's what we're trying to do. So we don't have the second volume, that's what we're trying to find. So our second pressure would be 105 kPa. And so that's how we put it on the other side. That's our second pressure. So to cancel it out,
Is it
we
360?
divide by
Yeah, so
there's no pressure. It's canceled out, so 45 divided on the other side. V2 is left alone. The second volume. Yeah, they get multiplied and
Well, not well.
Nothing, because temperature stays
But
constant.
like sometimes they do events with like all employees come at like at 9 p.m. And then it's like
you should go 195.
I haven't seen it in a minute. Last, well, no, I didn't.
You're dividing.
So the value of 15.
I don't think it's gonna be
So you get P2, and so that's your answer.
So este.
Este, y luego este.
¿Qué es este?
That's your divide. I mean, after you get over 60, you can break
Pues se los puesto tú cuántos
Up to 4.
Mr. Brand, can I go to the
That's all these are.
I don't know, can you? Okay. I'm not gonna argue with you then.
The only up to 4 is we haven't learned that stuff yet. No, it's constant.
Pues how much you have right now?
You only up to 4.
So how much you have?
Oh, 1060. It's 360.
Entonces quito el 3 de 0.
Yes. You're rounding it down.
Oh, alright.
Mr. Brand,
What?
Yep.
I think the first and the fourth question is the same.
Are they?
Yeah.
I know I'm being so proud
Yep, you're absolutely correct. Guess you only got to do 3, and we did 2 out of the 3 for you. Come up and grab a piece of scratch paper, ladies and gentlemen, when you're done.
Why not?
¿Quién te agarró uno?
Sí, gracias.
What am I supposed to do with Celsius?
Just you ignore it. It's not part of temperature's not part of cold law.
I literally looked at it and I saw the things that were comments and said things and I was like, I'm not.
It should always tell you in boils law, I think for sure. Like for example, it's a simple pressure with the that exerts over turn the pressure.
Oh, I have someone when I'm
Calculate the volume. And then we got volume. And again, what volume is needed for the pressure to cover.
Zero at the end. So it's not. It won't say that.
I'm so worried about this though, and I was just like, because I tried to look at the I was like, I don't know.
You're
Así que es que
way more than you lose. You're losing with gas.
Right? I'll give you 100.
I hate you. Exactly why. I don't know. It just feels like I'm writing this song.
Actually, I'm actually.
You and Lucas been taking practicing worship.
No, I don't have to worry about my hair.
Wait, what?
I already have.
Oh.
Okay, solve it. The gas has a pressure of 17.2 psi and a volume of 285 milliliters. What will be the gas's new volume in liters if the pressure becomes 485 millimeters of mercury?
Oh, yes, I Yeah, we have to convert. Because, but like, yeah, you have to get PSI of the movie. Not say 45. You get those PSI.
Wait, David.
What?
It's 17.2 PSI is.
Yeah. You have to like convert it.
By the way, ladies and gentlemen, just a reminder, tomorrow we will have a lab. I have your goggles in the back of the room, but if you do not have them with me, you need to bring them if you plan on doing the lab in class tomorrow.
Obviously, you can't change the value, so we would just write 106 and then 0, so that make it 366.
So,
Yeah, right. 25.
what's that?
No, B1.
Okay. Well, you've got a P1 and a V1, right? So Boyle's law says we set it equal to.
Oh, yeah.
B1 is 25.
Okay, so set it equal to P2V2. Which one are we solving for?
Now we're just converging.
Read the question again. Read the last half. Okay, so we're solving for P2.
Was that only for conversion?
So we've got to find another pressure. What's the other pressure? Okay.
Wait, what?
So put it into Boyle's law. You should be able to solve for it.
¿Y por qué le pusiste aquí?
I know what's going on. You have to
Oh,
set it up
because
and
that's the
then
second
see
one.
what it is.
That's P2.
So you need
P2 or B2? P2.
exactly.
Okay, so do PSI.
Oh, yeah.
Might be some helpful information for you, ladies and gentlemen.
That's PSI. That's this number of PSI.
No, it's just-
Is this right?
Yeah, it doesn't exist. What? Okay, so the second volume is 45 and HG, huh? And then the first one is 7.2 PSI. You want to get
Well, again, but I
these
have
PSI.
the number in my head. But if that number is correct, if you're converting it slightly,
Yeah. So 45 And it's like a web. So this is what we have, and this is one.
Oh,
So that you make sure that that's
and
what you're
that's
saying. Because right now,
And this is like
you're not selling for
one at or
you'd actually be
or
selling
what 14.7. These two are 1%.
Well, you should put what you're solving for in the top, because otherwise, technically, when you divide these, you've got one over here. Right here. So the other one. Also, because it is an M&A sheet for this.
How'd you get?
I use 14 PSI to so you would put the 14 I think this number.
I thought I was cooking, but I'm not cooking. You're divided by 1,000.
Oh, you got this.
So if you want to convert this number into PSI, this conversion right here, that is what you're going to use. Now the way we do the math is we take this number times this one divided by that. And that would be okay. You don't need to do any of this stuff on the bottom. Okay, pero ese sería cancel out you will in PSI.
This is
Now, you could have also, if you wanted to, convert
Yeah,
PSI.
I know.
Either way, doesn't matter.
Oh no, wait, oh, this is millimeters.
So when you do this, these units
Wait.
can be the same
So
size.
that's milliliters.
Y luego cuando vas a hacer I don't know what you're doing with this.
That was.
Oh my god, Josh.
That is the pressure. You put it easily over there. You either need to take this one.
That's milliliters. That's across the volume.
Well, here's the thing.
It's milliliters. And they're exactly for me.
Wait, the rest is 17.2 times 285. Is about half of that. So the number should be about half of that.
285.
Does not seem right.
Answer divided by this. That's your answer milliliters.
9 point.
Right, but what? You did 485. 38.
Yeah.
You did 45 times 14.7. You did 760 divided by 485. How you so you're gonna take this 400. So 9.38 is V2 at times.
You'll get there.
No. That's PSI. That's this in PSI.
That's good too. Like, all of this is pretty good. At the same time, it's just people with English.
Yeah.
So then you do 17.2 times 285. So you're here to
Yes.
room
Thank you.
214.
Okay, so I got this conversion for that one.
You got, slow down.
Okay.
At least you got
Okay,
this.
the closest sub.
I
So
What you got? You took it times 760.
And then I was looking at that, but I'm struggling with do I have to do that?
Well, you don't know. Then you do it after your
Yeah,
answer.
so like I need to.
But when you get your answer, you're going to need to go through milliliters into.
Yeah.
Do that after you get your answer.
Bro, what numbers are you giving in?
I'm one thing, that's why I don't put my.
Times.
Is that not allowed?
Well, here's what I'm wondering. Okay, now.
Then you did it wrong.
Let me talk to the class.
Okay.
What the fuck?
Please listen, ladies and gentlemen. Ladies, gentlemen, please listen. Those are our 4 standard pressures over here.
Bro, yeah.
What is the trick in this problem? What is the kink in this problem? What is the thing that I gave you in this problem that you have to do to solve it? What? Why?
They have to be the same
What has to be the same?
units.
The units for pressure. So I gave you a problem where I gave you 2 different units for pressure, right? Okay. So now you're going to do a little bit of conversion. Now, you do not have to be the greatest mathematician in the world, but please understand what I am about to tell you. The original pressure in PSI was 17.2, correct? Now, how is that compared to standard pressure in PSI? What's standard pressure in PSI? Okay, so 17.2 is what? Higher. So when you do your conversion, if you want to go from PSI into mmHg, your number is going to have to be bigger than what? Nope. Well, if that number there is bigger than this one, when I go to mmHg,
Bigger than 700.
it's got to be bigger than 760. Okay? The pressure that we're talking about is greater than this one. So when we convert it, if it was bigger than this standard pressure, it's going to have to be bigger than this one as well. Okay? So that's a little trick that you can use to say, okay, did I get a number that makes sense? So Josie, we were debating, was that supposed to be 88.9 or was that supposed to be 889? With that in mind, we realize that has to be 889, correct? Okay. What if we had a pressure of 0.5 ATMs? What would that be in PSI about? Why 7.3? Yeah. So if the numbers, when you're converting, if it was about half of this standard pressure, it's going to be about half of all of these. And I tell you that not because I expect you to do the math in your head, but just so that you can have an idea when you get your number. Did I set it up right? Did I do it right? Okay? So again, if your original pressure is bigger than the standard one of these, your new pressure in the new unit is going to be bigger than these as well. If it were smaller, it's going to be smaller. Okay? Now, here's the other thing. I don't care if you convert this from PSI into mmHg or this from mmHg into PSI. It doesn't matter. Okay? It doesn't matter which one you convert. So don't think, oh, I got to go to PSI because it's the first one. I got to go to mmHg because it's the same. You can do either one. Okay? You can do either one. So let's take a look at this, ladies and gentlemen. All right. So P1 times V1 equals P2 times V2. That's the only formula we've got so far. You're going to get a lot more of them. So again, I'm going to put in 17.2 PSI times the volume of 285 milliliter. And it's going to be equal to, but now I need to take this 485 mmHg and I need to convert it into PSI. So PSI has to go on the top, the 14.7. On the bottom goes the 760 mmHg. Now I am expecting a number that is about half of 14.7. Not exactly, but about half. Do you see why? 480, now it's not exactly half. 370 would be about half. But I'm figuring a number that is going to be a little bit more than half. So I'm figuring around 8, maybe 9, somewhere in there. When we do the math, what did we get here? Somebody. 9.38 PSI. Now I can put that in here. 9.38 PSI. Now, obviously, our pressure is going what? What's our pressure doing? Come on. What's the pressure doing? Decreasing. Which means what? Volume should increase. We do the math here. Divided by 9.38 PSI. Cancel and cancel. What you do to one side, you do to the other. PSI and PSI cancel. So what is our new volume, ladies and gentlemen? What is the new volume from 17.2 times 285 divided by 9.38? 0.523. Impossible. That I'll believe. Now, you worked a step ahead of me, Caden. Slow down. This comes out as 523 milliliters. And I'm assuming we rounded correct. Did we round correct? So maybe 522.8 or something like that. Okay, good. But now I need to convert this into what? Liters. So now, Caden, if you want to say 0.523 liters, that's fine. You do not have to show me how you ever go from milliliters to liters or liters to milliliters. You don't have to show me that. If you can't do that, you better do this. You better do the conversion. But understand, you don't have to show me. You are sophomores, juniors, and seniors in high school. I hope you know how to convert between milliliters and liters. I will give it to you. If you don't, do it. But that's a conversion that you should be able to do in your head. So just like I'm not going to grade you or make you show me how you figure out a formula mass. Well, 3 times 1.01 plus this times this. I assume you should know how to do this. Now, I'm going to grade you on if you get it right. So if you do this and you don't come up with 0.523, I'm going to mark it wrong. But you don't have to show me how you go from milliliters to liters. You do need to show me this. Okay? You do need to show me how you went from 485 millimeters of mercury into PSI. You would need to show me that. That's not an automatic. That's not, I don't think you have that in your brain, 14.7 over 706. I think you could do divided by 1,000 in your head. Multiplied by 1,000. That one I'll let you do, okay? Questions? Now that's how I can make these problems a little bit trickier. I can make you convert units within a problem. But in reality, that's all I can do to you. That's it. That's what Boyle's Law is. Questions? None, zero, zip, zilch? Okay. Put away all your stuff except for your periodic table and a calculator. I'm giving you way more time than you need for this quiz, ladies and gentlemen. 4. Giving you way more time than you need, but I would rather give you more time than not enough.
You're gonna get 20 out of 20. You're gonna get 50 out of
Okay. By the way, ladies and gentlemen, just so you know too, okay, and I'm not complaining about this with anybody. I just got an email from a student of mine saying, hey, I turned in this lab. Did you see it? Yes, when you turn things in, I see it. But if you're turning in a lab late, I'm not going to jump on it, grade it, and get it in the grade book. I have things to do in my life too. So normally if you turn something in late, well, within a week or so, I'll get to it. Normally by the end of the week. Okay? But understand, if you turn something in late and your parents are on your butt because your grade is lower than it should be, that's on you, not on me. I'll grade it when I get a chance. Okay? So Sunday night, Packer game gets boring or I'm watching something. I go to the labs. I grade them while I'm sitting there watching the TV. I'll return them to you when I'm done. Okay? But I'm not going to, well, you turned it in. I'm not going to go over to the computer and take time out to grade everyone that comes in every time. Okay? So please understand that. All right? Actually, you guys are doing pretty good. I am pleasantly surprised by how you guys have done both last trimester and this trimester. Okay? It's been a long time since I've taught chemistry, and you guys are making it kind of fun for me. Now, if you repeat that outside of this class, I will completely and totally deny it. Okay? But it has been pretty good so far. But here's the other thing. This is going to continue to get harder. Some of you are like, oh God, this is boring stuff. Yes, it is. But by the time we're done with this unit, you'll be doing some pretty tricky stuff, let's just say. Good luck, ladies and gentlemen.
Bye-bye, Morgan. Bye-bye.
When you're done, bring it up, set it on my desk.
Find something to quietly occupy your time. Quietly means, Eric, without talking. Just defining that for you in case you were uncertain.
Thanks.
Thank you. You do not need to show me the work when you are converting from Celsius to Celsius. Celsius to Kelvin or Kelvin to Celsius. You do on the backside for the conversions of pressure need to show me how you went from one unit to another. Yes. Make sure you get your calcium correct when you do this. It builds strong bones and good numbers.